All of us are familiar with the light, but visible light is just a tiny fraction of complete electromagnetic spectrum. So we have radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. Visible light wavelength is from 400 nanometer to a 700 nanometer. Longer the wavelengths, smaller the frequency, and shorter the wavelengths, higher the frequency. Speed equals to lambda wavelength times the frequency. Speed of the electromagnetic wave is the speed of light, which is equals to c equals to 3.0 times 10 to 8 meter per second. So that is c equals to lambda f. So which means f equals to c over lambda. If the wavelength is longer, frequency is smaller. If the wavelength is shorter, the frequency is higher. Radio waves has a longer wavelength and a smaller frequency, while gamma ray has shorter wavelengths but a higher frequency. In free space, all electromagnetic waves travel with the same speed of light, 3 times 10 to 8 meter per second. We use special symbol c for speed of light. C equals to lambda f. C is the speed of electromagnetic waves, lambda is the wavelength, f is frequency. The wavelength of a particular hue of a blue light is 475 nanometer. What is its frequency? This is a blue light, it's electromagnetic wave, and the speed is the speed of light, which is 3 times 10 to 8. So 1 nanometer is 1 times 10 to minus 9 meter, so that lambda equals to 475 times 10 to minus 9 meter. And c equals to lambda f, so that a speed is the speed of light, 3 times 10 to 8 equals to 475 times 10 to minus 9 times frequency. And the frequency equals to 6.32 times 10 to 14 hertz. What is the frequency and what part of the spectrum is it from? So this is displacement time graph, and period is the time taken for one complete oscillation. So we can find period from the graph, which is 6 times 10 to minus 16 second. And the frequency is 1 over period, which is 1 over 6 times 10 to minus 16. That is 1.67 times 10 to 15 hertz. It's a power of 10 to 15, so that must be ultraviolet here. What is the wavelength of this light wave? As we know, it is electromagnetic wave. All electromagnetic wave has the same speed of light. And we can utilize the formula above here. C equals to lambda f. And we can rearrange lambda wavelength equals to c over f. C is the speed of light, 3 times 10 to 8 over frequency from previous slide, 1.67 times 10 to 15, which is equals to 1.8 times 10 to minus 7 meter. C, determine whether or not this light is in the visible spectrum. The visible spectrum is from about 400 nanometer from violet to a 700 nanometer red light. 1.80 times 10 to minus 7 equals to 180 times 10 to minus 9, and that is 180 nanometer, which is not in the visible spectrum. Here's the animation of moving electric charge producing a changing electromagnetic field that propagates through space at speed of light. The red arrows represent the electric field and the blue arrows represent the magnetic field. A more smooth animation is shown here. First one is a mechanical wave and the second one is a light wave. The light wave is travel with the speed of light. Electric field oscillates vertically and the magnetic field oscillates horizontally, and that sets up electromagnetic waves.